All right, welcome back. We're still in Chapter 6, and now we're going to move on to Section 6.2, where we start learning about what are called trigonometric functions, which is really the focus of the course from this point on. Chapter 6, 7, 8, it's all about trigonometric functions. So the objectives here, first we have to learn what the trigonometric functions are, and then we're going to find values of them. They're based on using points on circles. Okay, and for certain quadrantal angles, you're in degrees 90, 180, 270, 360, in radians pi over 2, pi, 3 pi over 2. We're going to learn exactly what the values of these functions are. We're also going to find exact values of the functions at a couple other special angles, and we'll see how we get that later. So there are more objectives. This is a lengthy section. Find more and more exact values, but also how do I use a calculator to approximate the value of trig functions. Everyone's going to be happy to do that. And there we go. So what is the unit circle? This is a special term that's going to come up a whole bunch. It's a circle. Remember, any circle is defined by its center and its radius. So if I make the radius exactly 1 and the center exactly the origin, that is called the unit circle. Okay. It's just sort of like the most basic circle we could draw. Of all radii, what's the simplest? I guess 1 is a pretty normal number to use. Where's the easiest place to put the center? How about 0, 0? So this is like your basic reference circle. Notice that the circumference, because the radius is 1, the circumference is 2 pi times the radius, so it's just 2 pi. So in order to go around the circle once, a point must go a distance of 2 pi. Okay? So I wish they had a diagram here to go along with this. I'll try to draw one up here in the limited space we have. So here is my unit circle. Now remember, what is a function? A function says if you plug in a number, you get out a number, and it's unique and you can figure out what it is. So suppose I am on the unit circle. Okay, I mark off from this point right here, whose coordinates are 1, 0, I mark off an arc length of t. Now, since I am in the unit circle, remember that your arc length is the radius, which in this case is 1, times the angular measure, theta. So the arc length t will be the same as this angle, provided I'm measuring in radians. And the reason t is equal to theta is just because the radius is 1 because we're in the unit circle. But in any case, down in the bottom right, I'm going to sort of zoom in on this. Having marked off either an arc length of t or an angle of theta, where theta and t are the same number, either a radian measure or an arc length, the actual number will be the same because I'm in the unit circle. Can you agree, since I, by default, start at this rightmost point, 1, 0, if I mark off a length of t, I must be at a point, x, y, and that point, x, y, is completely determined by the length I move. If I move further, I'll be at a different point, but if I move the same amount of length, I will end up at the same place. So once you decide this is how far I want to go, alternately, once you decide this is the angle I want to put in the center, there is exactly one place on the circle you can be. In other words, if you plug in the angle theta or the length t, and they're the same number in the unit circle, so it doesn't really matter, but once you plug that in, you get out an x-coordinate and you get out a y-coordinate. There is no ambiguity about which coordinate you're going to get. I might not be able to find it exactly, but it's definitely there, and it's not going to change. So if you mark off this length or this angle, there is one place you can get. And I'm going to call that x, y, and it's completely determined by t. In other words, it's a function of t. If someone tells you, here's the length to go, or here's the angle to measure, there is now an x-coordinate and a y-coordinate associated with that point. And by definition, we call that y-coordinate the sine of t, or theta, and we call the x-coordinate the cosine of the angle or the arc length. And again, in the unit circle, it doesn't matter which way you describe it. Okay. Notice what I haven't introduced is anything to do with triangles. Some of you may have learned about sines and cosines in terms of triangles. Do your best to not remember that. It's not the preferred way to define these functions. Okay. The real way to define sine and cosine is in a circle. Specifically, in the unit circle, You start from the point 1, 0, you mark off an angle of theta, or you mark off an arc length of t, but they'll be the same number. Whatever the x-coordinate is, that's your cosine, and whatever your y-coordinate is, that's the sine. So go around the circle, starting from the rightmost point, going in the counterclockwise direction, and your x and y coordinates respectively tell you your cosine and sine of the angle or arc length. Okay. The tangent function is just the ratio y over x, but notice that y was defined to be the sine of t, and x was defined to be the cosine of t, so you could also call tangent sine t over cos t. The cosecant is 1 over y, that's 1 over the sine. The secant function is 1 over x, that's 1 over cosine, and the cotangent is x over y, that's cosine over sine. The most important ones, as you can now see, are cosine and sine. Everything else is defined using those. So really get a good understanding of what cosine and sine are, and then all you have to do is remember the definition. What's secant? Oh yeah, it's 1 over cosine. What's tangent? It's sine over cosine. And so if you know what sine and cosine do, you can figure out the rest from there. The one thing to bear in mind, and I didn't come up with these terms, so I'm sorry. Secant is 1 over cosine. Cosecant is 1 over sine. So the co versus the one that doesn't have co gets a little mixed up. Secant is 1 over cosine. Cosecant is 1 over sine. Okay, also try not to get in the habit of just writing things like this and expecting it to make sense to someone. These are functions. This is similar to like saying, oh, what number am I thinking of? Oh, it's square root. Square root of what? I mean, without anything in there, this isn't a number yet. Similarly, sine, cosine, tangent, without something to plug into them, they don't actually mean anything yet. So we all do it in our scrap work, where we just like to save time. We just write things like sine or cos. But at the end of the day, it's not a number if you aren't plugging anything into it. Okay, so let's try to find some values of trigonometric functions using a point on a circle. Okay, so P is the point -1/2 √3 over 2. Is this on the unit circle? Well, what's the distance to the origin? The origin has coordinates 0, 0, so use the distance formula. It's going to be the square root of 0 minus -1/2 squared plus 0 minus √3 over 2 squared. I'm applying the distance formula to measure the distance from P to the origin. Okay, -1/2 squared is 1/4. √3 over 2 squared is 3/4. 1/4 plus 3/4 is 1, and this is 1. So yes, this is distance 1 to the origin. It is in fact on the unit circle. So if that point is on the unit circle, suppose that t is the arc length to get there. Alternately, you could say theta is the angle to get there. So what are all 6 trigonometric functions of this angle or arc length? So for example, the sine of the angle, I prefer working with the angle rather than the arc length. But again, since we're in the unit circle, the angle measured in radians is the same number as the arc length. So the sine of the angle is the y-coordinate of the point. And what's the y-coordinate of the point? √3 over 2. So similarly, go ahead and work through what are the cosine, tangent, cosecant, secant, and cotangent of this associated arc length t or angle theta. So pause here, write them all down. We'll double check in a moment. Okay, so the x-coordinate is -1/2, the y-coordinate is √3 over 2. So as we already discussed, the sine is √3 over 2. The cosine is the x-coordinate, which is -1/2. The tangent is that ratio of y over x, which simplifies down to -√3. The cosecant is 1 over y, so it's 2 over √3, or just 2 √3 over 3, either way. Normally what I would do, by the way, I would just say cosecant is 1 over sine. So I would just flip this, and I'd say 2 over √3, and I'd call it a day. I am not a stickler for saying you can't have radicals in the denominator. In previous courses, you may have been told, don't do that. There are reasons to not do it by habit, but I'm not one who really is going to kick up a fuss about that. So if you just left it as 2 over √3, that'd be fine. The secant is 1 over negative 1/2, which simplifies to negative 2, and the cotangent is either 1 over root 3, or if you don't want the radical in the denominator, negative root 3 over 3. So because the angle and the length are the same in the unit circle, as long as you're measuring the angle in radians, we can also talk about trig functions, sine, cosine, tangent, cosecant, secant, cotangent. These are called the trigonometric functions, or just trig functions. We can plug in angles rather than arc lengths, and actually the angle is the standard thing to plug in. So find the exact values of all 6 trigonometric functions, sine, cosine, tangent, secant, cosecant, cotangent, of each of the following angles. Okay. So I will, for example, do part B. Okay. So in the unit circle, starting from this point or this direction, going straight right, I want to measure off an angle of 90 degrees or pi over 2 radians, exactly pointing straight up. I then ask, what are the coordinates of that point on the unit circle? Well, the x-coordinate is 0 because it's pointing straight up, and the distance from the origin is 1, so it must be 0, 1. So now I know the x and y coordinate given by the angle of pi over 2 radians. So now I can just start applying that the sine of pi over 2 must be the y-coordinate, which is 1. The cosine of pi over 2 must be the x-coordinate, which is 0. The tangent of pi over 2 is y over x, y over x, which is 1 over 0, which is undefined. You can't divide by 0. The secant of the angle is 1 over x, which is 1 over 0, which is undefined. The cosecant of the angle is 1 over y, and that's just 1 over 1, that's 1. And the cotangent of the angle is x over y, which is 0 over 1, which is 0. So the sine of pi over 2 is 1, the cosine of pi over 2 is 0, the tangent and the secant of pi over 2 are both undefined. The cosecant of pi over 2 is 1, and the cotangent of pi over 2 is 0. So use similar reasoning to do parts A, C, and D, and pause the video here and work through all of that, and then we'll double check everything. Okay, so an angle of 0 points straight right, and the coordinates of that are 1, 0, which gives us the sine as the y-coordinate, which is 0. The cosine is the x-coordinate, which is 1. The tangent is 0, the secant is 1, but here, since the y-coordinate is 0, you can't divide by it, so cosecant and cotangent are not defined. B is the one that we did. Okay. So sine and cosecant are both 1, cosine and cotangent are both 0, but since the x-coordinate is 0, you can't divide by it, and therefore tangent and secant are both not defined here. Okay. 180 degrees points directly left, pardon me, and the coordinates of that point are -1, 0. So the y-coordinate is 0, that's the sine. The x-coordinate is -1, that's the cosine. The tangent is y over x, which is 0. The secant is 1 over x, which is also -1. But again, since the y-coordinate is 0, cosecant and cotangent aren't defined because you can't divide by 0. And finally, part D, 3 pi over 2, 270 degrees, points straight down, so the coordinates are 0, -1. So the sine is the y-coordinate, which is -1. The cosine of 3 pi over 2 is the x-coordinate, which is 0. The cosecant is 1 over the y-coordinate, which is -1. The cotangent of 3 pi over 2 is the x-coordinate over the y-coordinate, which is 0. And again, the x-coordinate is 0, can't divide by it, so tangent and secant of 3 pi over 2 are not defined. So hopefully we got all of that. So here is a nice little chart that basically summarizes everything we just talked through. I would not say you have to memorize this. Don't try to think, gosh, this is a big chart, I need to memorize all of it. No, what you need to remember is, if you start from this direction, straight right, and you measure off an angle of theta, this point has coordinates x, y, but x is the cosine of the angle and y is the sine of the angle. That's what you need to remember. You can always figure this stuff out again on your own just by asking, oh, I mark off an angle of 270 degrees, that's 3 pi over 2, that's 3 quadrants, I'm pointing straight down. Since this is straight down, and I'm on the unit circle, I'm at 0, -1, So now I know the cosine is 0 and the sine is -1, and I can figure out the rest from there. It's less effort to actually know how to find sine and cosine in general than it is to try to memorize a big chart, because we're going to get more charts in a minute anyway. Okay, so this is going to do it for this video. Okay, but if you come back for the next one, we'll do just a bunch of like word problems and computing more and more examples. Okay, sine, cosine, tangent, these trigonometric functions are the main focus of, I am not exaggerating, the rest of the course. So we're going to really get to know them in detail.